Unit 2 homework FRQ. So what we're looking at here, first of all, make sure you read all the directions. It says the graph of the function f in the table of selected values for f of x are shown above. The graph of f of x has a horizontal tangent line at x is equal to 2. So guess what? That piece of information is actually important right here. So I'm just going to highlight that. We probably will need it later. And then concave up means it's just curved upwards. We'll get to that in a unit, I think, 5. But it just means that it's curved upwards like a cup, up like a cup. And then it's linear from x is greater than or equal to 5. At A, for part A, approximate the value for f prime of 4.5 using data from the table. So then you have to use data from the table. Now, we want to do it at 4.5, but you have to be really careful because you do not want to use, I know normally we surround the 4.5, so we would use this point here that I'm highlighting and this point here. However, you got to pay attention to the graph. In this case, the graph would give me the wrong slope. It would give me a negative slope. It would find the slope between these 2 points or that segment I just drew in highlighter. So instead, the better estimate would have to be using 4.5 instead. So it wouldn't be a good choice to use 5, 1 as an ordered pair. So just be really careful. Don't be too, you're used to doing it this way, so then you have to also relate it to the graph. A couple of things, make sure you use approximation symbol here. It's not equal to, we are approximating. So when you're approximating in this case, you have to indicate that. We're using the slope of the secant really to help us approximate it. So it's not actually the derivative, it's just an approximation thereof. So we have to remember to do that. In part B, is there a value of x on the interval from 0 to 5 such that this limit is equal to 0? Well, that limit we know is one of the definitions for the derivative at that point. So that means you need to make sure you have stated that you understand that it's the derivative. So we're going to write here f prime of x is equal to, so since I know that, f prime of x is equal to 0 where the graph has a horizontal tangent. We also know that because that's the slope of the tangent line. And we're told in the directions that happens at x is equal to 2. So you have to give a reason for your answer, so you're stating that you know that limit is the derivative, and we take that derivative set equal to 0, which we also know that would be the graph of, or the slope of the tangent line. So that we mentioned both of those things in our work here. That's part B. Okay, part C. I went through this, I went through it a couple of times because I realized, first of all, I see that it's the definition of a derivative at 5. However, if I'm doing it from the left and from the right, so here, this one is doing it from the right, which is pretty straightforward because from the right, it's a line segment, and the slope of the line segment is 1/4. You just look up at the graph on the right-hand side here, that slope, you go up 1/4, okay, that's 1/4. It's the other side that's a little more problematic because now that I looked at it, if I look at it and I asked you for f of x plus h minus f of x over h at the limit there, that would be slightly different. But I just realized here that, look, it's asking you to take the derivative from the left-hand side, but you have to use f of 5. Now, f of 5, I know, is 1 based on both the table and the graph. And f of 5 plus h, where h is approaching 0 from the left, is these values here. So from the left, let me highlight that. These values here, we are approaching, in this case, 4. So 4 minus f of 5 is 1. So in the numerator, we end up with something that approaches 3. But in the denominator, so here I wrote this out, as h approaches 0 from the left-hand side, f of 5 plus h approaches 4. And I know that f of 5 is 1. So that means the numerator's value is 3, but the denominator approaches 0 because that's the h. So therefore the limit doesn't exist. It goes to an infinity here, right? So in this case, that one would not exist for number 2. For number 3, it doesn't exist for multiple reasons. One way you could say, since the one side, one of the limits, in this case it's the left-handed limit, doesn't exist, that means that the limit at 0 would not exist because it has to approach the same value and it has to exist on both sides, the left and the right. That's one explanation. That's this one I put over here on the right-hand side. Another one is to state, oh, I know that this is the definition of the derivative at 5, and since f of x has a jump discontinuity at 5, f of x is not differentiable at x is equal to 5, so therefore f prime of 5 doesn't exist, or the limit doesn't exist. Both of those answers work just fine, okay? So that's part C.